This video is a brief introduction to trigonometry using a resource other than our textbook, and that resource is what you see here, the web page or website, Math is Fun, and specifically their web page, Introduction to Trigonometry. And I have provided the link to this web page in the description of this video. So first of all, trigonometry means triangle measure. And really, that's all we're doing with trigonometry. We're looking at measures of triangles, most often right triangles, and that's going to be our main focus for our course. We have already seen some things about measuring triangle sides using Pythagorean theorem. We've seen some things about how the sum of the angles in a triangle add up to 180 degrees. That's just angles only. But in each case, it's either just sides or just angles. And what we're going to explore here in this next chapter of our course anyway, is this relationship between sides and angles. So again, our most used triangle is going to be the right angled triangle. And we have labeled legs of triangles before, or sides rather, of triangles before, but not like this, not in our course yet. So this particular labeling uses the perspective of an angle, and that angle is called theta. Theta is a very commonly used notation for angles in triangles. So what we see here is that, first of all, the best way to do this, in my opinion, is to go ahead and label the hypotenuse. The hypotenuse is the longest side. It is also directly across from the right angle, as you can see here. From there, now look at your angle theta and identify what is the side opposite that angle. As if you were looking through the angle, then you should approach the opposite side. And then last, the angle the ray that would create the rest of this angle would have to be the adjacent side to that angle. Now notice some people may say, okay, well, the hypotenuse is also adjacent. Okay, and that may be true if this were not part of a right triangle, but the hypotenuse is very special because it's the longest side and it's opposite the right angle. So in my opinion, go ahead and label that one first, hypotenuse, and then you can better identify which legs are opposite and adjacent. Moving along this web page, here's a couple of really brief examples of why you would want to do this, or why this is important. And in this particular case, let's say you have the leg measures. You could get that direct distance or the hypotenuse with Pythagorean theorem. That's true. But to get the angle measure, we would need something more. Okay, and that's what we're building up to here. Or maybe you have that direct measurement link. Think of it kind of like as the hypotenuse of a right triangle, and you know the angle measure in a standard form, and you want to find how far left, right, or up, down you would have to go to, say, plot that point in this case. So again, this is what we're building up to, as a combination of using sides and angles in a right triangle to solve or determine other sides and angles in the right triangle. And this is where sine, cosine, and tangent come in. These are our major functions of trigonometry, or trigonometric functions. There are some other ones listed in our text, but again, this video is just a brief overview of an introduction to trigonometry, something that I feel is kind of missing in our textbook. So here they are defined using this particular right angled triangle and the angle theta. So sine of theta is defined as the opposite side length divided by the hypotenuse length. Sine of theta is opposite over hypotenuse. And this goes for any angle theta. Okay, I know theta right here is this particular theta, but we could do the same thing with other right angle triangles. Cosine of theta is the adjacent side over the hypotenuse. So in this case, this is where it's so important to correctly identify what's the adjacent side length, and then we could divide that by the hypotenuse length, and we come up with the cosine of that angle. And then the tangent is opposite over adjacent. So tangent of theta is the opposite side over the adjacent side length. Now these are abbreviated: sine, cosine, and tangent. Notice I'm still saying the full phrase, sine, cosine, and tangent, but those abbreviations are commonly used on your calculator. So let's see what that means. What is, for instance, the sine of 35 degrees? And we're going to use this particular right triangle, and lengths are only, it says, are only to 1 decimal place. So sine of 35 degrees, if we want to determine that for this triangle, we would first grab the opposite side length. Because remember, sine of theta is opposite over hypotenuse. So that opposite length is 2.8. Next, we would grab the length for the hypotenuse, which is 4.9. We divide those because these are trig ratios. That's another way you may see them defined. And we get that sine of 35 degrees is 0.57 approximately. What is really interesting is that triangle could be larger, smaller, turned around, but that angle will always have this ratio, 0.57. And you're going to start to see that as you practice additional problems. That sine of an angle is always this ratio, opposite over hypotenuse, and have this particular measure in this case. So up next, let's look at how our calculator can help us solve more of an application problem. Let's say we want to know, how tall is this tree? We can't reach the top, so we walk away, we measure an angle using a protractor, let's say. We measure the distance from that point using a laser. And so really what we know is we know this hypotenuse, and we know theta from the point where we measured that angle and where we measured that distance. What we want to find is the opposite side length of this assumed right angle, or right triangle, I'm sorry. Sine is defined as the ratio, sine of an angle, is defined as the ratio of opposite over hypotenuse. So what we do then is we have sine of 45 degrees is opposite over hypotenuse. So notice we're starting to plug in some things that we know into this specific trig ratio. We can get out our calculator, we can type sine 45, and that may look like this again on your calculator using that sine key. You do want to be very sure that you are in degree mode if you're using degrees for your angles, and we can talk more about that later for your particular calculator. Next, you want to plug in other things that you know. So like in this case, you know the hypotenuse, you don't know the opposite side. That's what you're eventually looking for. All right, so our calculator gave us this approximation, this decimal approximation, 0.7, okay? And we plug in the hypotenuse that we know, which is 20. We multiply both sides by 20, and we get the length of the opposite side. And that opposite length is 14.14 meters. So if we come back to this tree, and again, thinking about how I recently asked a question about how do you know that you check the reasonableness of your answers. And we all have these types of experiences where we look at, say, the height of something unknown. We know that this distance from, say, our feet to the top of it may be 20 meters. Just imagine what 20 meters looks like with an angle of 45 degrees. And it would be reasonable for that tree to be something less than 20 I mean, it has to be because it's a right triangle, right? But not significantly less than 20. So 14 meters sounds reasonable. Okay, so moving on, on the website, it mentions that you may get a little bit faster with this, and it shows another example here of how you could probably speed up that process just a little bit. After that, there is this little interactive feature that I would really like for you to try. You can move this point along the circle. You can click on other things in this circle, like highlighting quadrants, let's say, or angles along this circle. And this is a really cool tool that kind of wraps up some other concepts even from previous sections as well about angles in standard form and angles on what we call a unit circle. So I encourage you just to play around with that. And as you do, notice the sides that are showing up here in blue and green. Okay, and notice what they appear as up here as cosine, sine, or tangent as well. Okay, so I'll let you try those things. And they give you some other suggestions here as well. So what this means then is that triangles are actually related to circles, and in particular, the unit circle. The unit circle is defined as a circle whose center is the origin, and that would be this point 0, 0, where the x and y axis meet, and whose radius is 1 unit. Okay, so, and here's that radius shown here on this particular circle, and we can see some clear endpoints of this circle and where they would touch the x or y axis. For our particular course, we're not going to go into great depth with the functions that are defined by the unit circle, but this is another one of those interactive features that you can kind of play around with and see how we can actually create graphs where along the x-axis we have the measure of the angle theta, and along the y-axis, like in this particular case, we're looking at sine of theta. Or it should be sine of theta. It looks like, yes, it's sine of theta. Okay, so moving on, there's some mention here about degrees and radians. We have seen some of that in the past. So just note as well in this chapter, you're reminded of that conversion. You're also you see a new conversion of changing decimal degrees into degrees, minutes, seconds. And I have a separate video about that. So skipping along, because we're not going to concern ourselves with the graph in this case. I'm going to keep moving on down to solving triangles. Here's an example where we're solving a triangle by finding a missing angle. And notice that they're using the fact that the angles of a triangle add to 180 degrees. And however, let me go back. However, that's about all we can do with the trig that we know at this point. Okay, so let's keep on moving to other trig functions. Cotangent, secant, and cosecant. Notice these are reciprocals of other trig functions that we have, sine, cosine, and tangent. That's a little bit better defined in your textbook as well. And last, we have some trig identities, and you can learn more about those things here by clicking along these links. I believe that's everything for this particular section, so I'm going to scroll all the way back up to the top. If you want to see a little bit more about just sine, cosine, and tangent, here's an additional web page. I'm not going to go through all of this, but I just wanted to hit some of the highlights with you here in this video. Again, there's some other interactive features. There's a couple of examples for you to try, as well as a way to memorize these trig ratio definitions using what we call SOHCAHTOA. And it's another of the same interactive feature. So you can see here there's some other things here that are provided. So again, in the description, I'm going to provide these 2 links to these particular web pages on the Math is Fun websites for you to further explore, get a better handle on some of the introduction part to trigonometry. Also, again, remember, this is just a supplement to what's in your textbook. So your textbook has additional resources, more definitions. So just use this as a supplement.